equals 8 raised to power y plus 7. Don't forget, this is an Olympiad question. And before we proceed, don't forget to like, subscribe to my YouTube channel. Yeah, today we are going to proceed with this. And for us to proceed, we are going to make use of the rules of indices. And don't forget that when you have s raised to power a times s raised to power b is the same thing as s raised to power a plus b. So these rules will be applied to this. So here I'm going to have 7 raised to power y times 7 raised to power 8 equals 8 raised to power y times 8 raised to power 7. Okay, so with this we can divide both sides by 8 raised to power y times 7 raised to power 8. So we divide both sides by that. So with this, 7 raised to power 8 is going to cancel out 7 raised to power 8. 8 raised to power y is going to cancel out 8 raised to power y. So I'm going to be left with 7 raised to power y divided by 8 raised to power y equal 8 raised to power 7 divided by 7 raised to power 8. And also, I can, using the law of indices also, I can bring out this power out. So here I'm going to have 7 raised to over 8, everything raised to power y equals 8 raised to power 7 over 7 raised to power 8. So to both sides now, I'm going to introduce logarithm to both sides. And here I can have log this, also log this. Okay, and there's another rule for logarithm. When we have log a raised to power b is the same thing as b log a. So this is now going to be in form of my a, while this is going to be in form of my b. So this can possibly come to the back. So with this, I'm going to have y log 7 over 8 equals log 8 raised to power 7 over 7 raised to power 8. Now, I can make y subject of the formula from this. So dividing both sides by log 7 over 8 log 7 over 8. So at the left hand side here, I'm going to have y equals log 8 raised to power 7 over 7 raised to power 8 divided by log over 8. So I'm going to use another law of indices, logarithm, that says that log a divided by b is the same thing as log a minus log b. So with this, I'm going to have log for the numerator 8 raised to power 7 minus log 7 raised to power 8. Also for the denominator, the same rule will be applied. So here I'm going to have log 7 minus log 8. That is what my value of y equals to. And from here, we can possibly say, using this same law that says log a raised to power b is the same thing as b log a, so the same thing can be applied here. So my y will be equals 7 can go to the back. So 7 log 8 minus 8 log 7, everything over log 7 minus log 8. And using our calculator, we are going to have that log 8 is the same thing as 0.9031, and also my log 7 equals 0.8451. So my y is going to be 7 into bracket 0.9031 minus 8 into bracket 0.8451 over 0.8451 8451 minus 0.9031. So solving this, my numerator is going to give me minus 0.4391 over minus 0.058. So finally, I can say that my y is approximately going to be 7.571. So this is my final answer. Please don't forget to subscribe to my YouTube channel. Also like and also share. Welcome to another math class. Today we shall be solving this math Olympiad question, and here we have that x plus xy plus y equals 54. So from here we should know that this can be written as x plus xy plus y equals 54, which is the given equation. So factorizing out here, we have x into bracket 1 plus y equals 54. And our intention is to find x plus y. So from here, we can add 1 to both sides, okay? So adding 1 to both sides, here we have x into bracket 1 plus y plus 1 plus y equals 54 plus 1. So with this, we can have x into bracket 1 plus y plus 1 plus y equals 55. So with this, 1 plus y can be factorized from these two expressions. Here we have x plus 1 left equals 55. Now solving this forming a simultaneous equation from this, because looking at the factors of 55, we can say that 1 times 55 gives 55, okay? And also we know that 5 times 11 gives 55, and also 11 times 5 gives 55, and lastly 55 multiplied by 1 also gives 55. And our condition here is that x and y are positive integers, and for our x and y to be positive integers, it shows that the value of our x must be greater or equals to 1, and likewise the value of my y must be greater or equals to 1. And looking at this, what satisfies this condition is only 5 and 11, okay? These are the two conditions that satisfy this, because in this case now, our x is not greater than 1, and here my y is not greater than 1. So we are considering these two conditions. So now, solving further here, I can have that my x plus 1 is equal, this is when we have this to be 5, and also my y plus 1 is also equals to 11. This is the first condition. And second condition is that it can be that my x plus 1 equals 11, while my y plus 1 equals 5. Okay, that means s can be 11 and s can be 5 and s can be 11, and otherwise y can be 11 and also y plus 1 can be 11 and also y plus 1 can be 5. So now solving this simultaneously, you will agree with me that from here my x is the same thing as 4, and also from here my y is the same thing as 10. Just the same thing here, the value of x can be 10, and from here the value of y can be what? 4. So solving either way, my x plus y equals 14, and this solve our question. Math class. Today we shall be solving this Olympiad math question. Now here we have 0.01 all raised to power x equals to 11, and here the first thing we are going to do is to apply the law of logarithm. But before we proceed, kindly subscribe to my YouTube channel. Thank you. So here, applying the logarithm, we have log into bracket 0.01 all raised to power x equals log 11. And don't forget the rule of logarithm that says that when you have log a raised to power b, this is the same thing as saying b log a. So we are using the same thing. So this is coming to the back. So here we have x log 0.01 equals log 11. In addition to this, also we know that 0.01 is the same thing as saying 1 over 100, right? Which is the same thing as saying 10 raised to power negative 2. So using the same thing here, we are going to change 0.01 to 10 raised to power negative 2. So we have x log 10 raised to power negative 2 equals log 11. So applying the first law here, which is log a raised to power b, the same thing will be used here. So here we have negative 2x log 10 equals log 11. From the basic knowledge of logarithm, we know that log 10 automatically adds the base of 10, and log 10 base 10 is the same thing as 1. So here at the left hand side here, we are going to have negative 2x equals log 11. So from here, dividing both sides by negative 2, so here I'm going to have x equals negative 1 over 2 log 11. And still using the first law of logarithm here, here if I have b log a, it's still the same thing as saying log a raised to power b, right? So using the same thing here, I'm going to have my x to be equals to log 11 raised to power negative half. So from this, my x is the same thing as saying log 1 over root 11. And from the law of surd, in my previous video, I did the law of surd. So using one of the laws, I think that is the last law. So using it, when you have 1 over root 11, so rationalizing this means multiplying both numerator and denominator by the denominator. So here I'm going to have root 11 over 11. So you can check my video on law of surd on this. So from this, my x is now going to be log root 11 over 11. So this is the value of our x. Thank you very much for watching my video, and I will surely appreciate. Hello viewers, welcome to Olympiad Math class. Today we shall be solving this question, which is 7 raised to power y plus 8 equals 8 raised to power y plus 7. Don't forget, this is an Olympiad question. And before we proceed, don't forget to like, subscribe to my YouTube channel. Yeah, today we are going to proceed with this. And for us to proceed, we are going to make use of the rules of indices. And don't forget that when you have s raised to power a times s raised to power b is the same thing as s raised to power a plus b. So these rules will be applied to this. So here I'm going to have 7 raised to power y times 7 raised to power 8 equals 8 raised to power y times 8 raised to power 7. Okay, so with this, we can divide both sides by 8 raised to power y times 7 raised to power 8. So we divide both sides by that. So with this, 7 raised to power 8 is going to cancel out 7 raised to power 8. 8 raised to power y is going to cancel out 8 raised to power y. So I'm going to be left with 7 raised to power y divided by 8 raised to power y equal 8 raised to power 7 divided by 7 raised to power 8. And also, I can, using the law of indices also, I can bring out this power out. So here I'm going to have 7 raised to over 8, everything raised to power y equals 8 raised to power 7 over 7 raised to power 8. So to both sides now, I'm going to introduce logarithm to both sides. And here I can have log this, also log this. Okay? And there's another rule for logarithm. When we have log a raised to power b is the same thing as b log a. So this is now going to be in form of my a, while this is going to be in form of my b. So this can possibly come to the back. So with this, I'm going to have y log 7 over 8 equals log 8 raised to power 7 over 7 raised to power 8. Now, I can make y subject of the formula from this. So dividing both sides by log 7 over 8 log 7 over 8. So at the left hand side here, I'm going to have y equals log 8 raised to power 7 over 7 raised to power 8 divided by log 7 over 8. So I'm going to use another law of indices, logarithm, that says that log a divided by b is the same thing as log a minus log b. So with this, I'm going to have log for the numerator 8 raised to power 7 minus log 7 raised to power 8. Also for the denominator, the same rule will be applied. So here I'm going to have log 7 minus log 8. That is what my value of y equals to. And from here, we can possibly say, using the same law that says log a raised to power b is the same thing as b log a, so the same thing can be applied there. So my y will be equals 7 can go to the back. So 7 log 8 minus 8 log 7, everything over log 7 minus log 8. And using our calculator, we are going to have that log 8 is the same thing as 0.9031, and also my log 7 equals 0.8451. So my y is going to be 7 into bracket 0.9031 minus 8 into bracket 0.8451 over 0.8451 minus 0.9031. So solving this, my numerator is going to give me minus 0.4391 over minus 0.058. So finally, I can say that my y is approximately going to be 7.571. So this is my final answer. Please don't forget to subscribe to my YouTube channel. Also like and also share. Hello viewers, welcome to the math class. Today we shall continue with our videos. And today, we'll be solving 2 raised to power a minus 2 raised to power b minus 2 equals 2016. Before we proceed, don't forget to like and subscribe to this channel. So, with this question, we are going to use the rule of indices. And the first rule we are going to be using here is that don't forget that when you have s raised to power a over s raised to power b is the same thing as s raised to power a minus b. That is the first rule we are going to make use of today. So, applying the same rule here, we are going to have 2 raised to power a divided by 2 raised to power b minus 2 raised to power 2 minus 2 raised to power b divided by 2 raised to power 2 equals 2016. And don't forget that 2 raised to power 2 is equivalent to 4. So this is the same as saying 2 raised to power a over 4 minus 2 raised to power b over 4 equals 2016. Multiplying 2 by 4. So we are going to have 2 raised to power a minus 2 raised to power b equals 4 times 2016. So here is the same thing as saying 2 raised to power a minus 2 raised to power b equal 8064. So let's call this our equation 1. Now we are going to form equation 2. Okay, since that we have 2 raised to power a minus 2 raised to power b, one thing we are very sure of is that our 2 raised to power a minus 2 raised to power b, the value is surely greater than 0. We are very certain of that. So it tells us that our a will be greater than our b. We are certain of that. So now I'm going to say let my a to be equals to b plus, let's say, y. Okay, where my y is an integer. So let a equals b plus y, where y is an integer. Now going back to this equation 1, this equation 1 can be written in another form. Since my a is now equals to b plus y, so I can say that my equation 1, so rewriting equation 1. So I'm going to have 2 raised to power b plus y minus 2 raised to power b equals 8064. So using the law of indices that says that s raised to power a, s raised to power b is the same thing as s raised to power a plus b. So here I'm going to have 2 raised to power b, 2 raised to power y minus 2 raised to power b times 1 equals 8064. So with this, factorizing out 2 raised to power b, which is common to both sides. So here I'm going to have 2 raised to power b factorized out, which is going to give me 2 raised to power y minus 1 in bracket equals 8064. So I'm going to have this in bracket. So with this, using the LCM method, that's going to be a long process, but using the LCM method, we are going to have that 8064 is equivalent to 2 raised to power 7 times 63. Yes, you can do this and you will see that this is equivalent to 8064. So I can transform this equation to 2 raised to power b into bracket 2 raised to power y minus 1 equals 2 raised to power 7 times 63. Now comparing these two, you can see that this is equivalent to this, while this is equivalent to 63. So here I can say that my 2 raised to power b equals 2 raised to power 7, while also my 2 raised to power y minus 1 is equals to what? 63. Minus 1. So from here, equality of base. So I have that my b equals 7. And here I have that my 2 raised to power y equals 63 plus 1. So my 2 raised to power y is the same as 64. My 2 raised to power y is also equals to 2 raised to power 6. And here I can say my y equals 6. Now I have equals 7, my y equals 6 also. And don't forget that we are interested in getting the value for the a and also for b. So, and from this, we have that our a equal b plus y. So now, since our a is equals to b plus y, so my a is now going to be 7 plus 6, and finally my a equals 13. So in conclusion, I have that my a is 13 and also my b is 7. Thank you very much for watching my video. I really appreciate you all for subscribing, and don't forget to subscribe if this is your first time of watching my videos. Hello viewers, welcome to the math class. Today we'll be solving this question on Olympiad. Before we proceed, if this is the first time of watching our videos, we say a very big thank you to you, and please don't forget to subscribe. And to our returning viewers, thank you very much. Today we have the 147 raised to power x equals 189. Then look for what is the value of 7 raised to power 1 minus 2x over 3 into bracket x minus 3. Now for us to do this, don't forget, here we are having 147, and then 147 can be written as the multiple of what? 49 and 3. So our 49 can be written as 7 raised to power 2 multiplied by 3. Also, we have that 189 can be written in the form of 7 multiplied by 27, and 27 also can be written in the form of what? 3 raised to power 3. Now, having known this, we are coming back to this, and from here, so our 147 can be written in this form of 7 raised to power 2 multiplied by 3 all raised to power x equals 189 can be written as 7 multiplied by 3 raised to power 3. So now rewriting this, we know from the rule of indices that if you have x y raised to power a is the same as saying x raised to power a multiplied by y raised to power a. So adopting the same method to solve this further, we have 7 raised to power 2x multiplied by 3 raised to power x, which is equal to 7 multiplied by 3 raised to power 3. Okay, solving further now, this is almost the same thing as having 7 raised to power 1. Okay, 7 raised to power 1 is equivalent to 7. Now we intend to make the 7s to be on one side and the 3s to be on the other side. So we can do that by dividing both sides by 7 raised to power 2x multiplied by 3 raised to power 3. 7 raised to power 2x multiplied by 3 raised to power 3. Okay, so this can possibly cancel out. Also, this can cancel out. So at the left hand side, we are having 3 raised to power x divided by 3 raised to power 3 equal 7 raised to power 1 divided by 7 raised to power 2x. Now using the method of indices again that we have when s raised to power a over s raised to power b, the division rule, we are going to have s raised to power a minus b. You can check some of our videos on indices. Now At the left hand side here, we are having 3 raised to power x minus 3 equals 7 raised to power 1 minus 2x. Now, in order to simplify this further, multiply the root of both sides by 1 over x minus 3. 1 over x minus 3. So here x minus 3 can cancel out. Oh, okay. Let's proceed with this. We are having 3 on this side equal 7 raised to power 1 minus 2x over x minus 3. So we want to multiply the root of both sides by 1 over 3 again. 1 over 3, yeah. So here we are going to have, at the left hand side here, we are having the cube root of 3 equal 7 raised to power 1 minus 2x all over 3 into bracket x minus 3. Now looking at this and this, you can see that this correspond with what we have here. So that means the value of this is the same as square root of 3. So finally, coming back here, we can say that this is equal to what? Cube root. From here, it should be the cube root of 3. So this is equivalent to the what? The cube root of 3. Or we can say that it's equal to 3 raised to power 1 over 3. Thank you very much for watching my video. Please don't forget to subscribe to my channel. See you next video. Thank you. Hello viewers, welcome to Ajadi Maths class. Today we'll be solving this mind-blowing Olympiad question. Before we proceed, please kindly subscribe to our channel, like and comment on this video. Thank you. Now looking at this, we have if x plus 1 over x equals minus 1, find x raised to power 8 plus 1 over x raised to power 8. So this is unknown. Okay. Now the first step we are going to use here is to work on this equation given to us, and looking at that, our step 1. Okay. Now we have x plus 1 over x equals minus 1. Now finding the LCM of these, we have the LCM to be x. Let me divide this into 2. So finding the LCM of these, we have 1 in x to be x, multiplied by this, we have x squared. X in x is 1, multiplied by 1, we have 1 equals minus 1. Okay, cross multiplying this, we have x squared plus 1 equals, this multiplying minus 1 gives minus x. So combining this into an equation, we have x squared plus x plus 1 equals 0. Okay, let that be our first equation. Now our step 2. Don't forget that if we have a raised to power 3 minus b raised to power 3, this can be written as a minus b into bracket a squared plus 2ab plus b squared. Okay, this is the basic expansion theory that we all know. So if we expand this, we are going to add the left hand side. So now using this equation to form this, given that we have s cube minus 1 cube, so comparing it with this, we are going to have what? X minus 1 x squared plus 1 times x plus 1 square. Okay, so that means this can be written more explicitly as s minus 1 x squared plus x plus 1. Okay, and don't forget that this, from this equation given to us, let me call this equation 3. Okay, from this equation 3 given to us, the value is equivalent to what? 0. Okay, so that shows that our s cube minus 1 cube is the same as s minus 1. This is now 0 times 0. Okay, this shows that we have s cube minus 1 cube is the same as 1 equals 0 times any value is what? 0. So s cube will be equals to 1. Okay, now we've known this. Okay, now let's go straight to step 3. We are going straight to step 3. Now in our step 3, don't forget that we have s raised to power 88 plus 1 over s raised to power 88. Okay, so now let's rewrite this. We have s raised to power 88 plus 1 over s raised to power 88. Now splitting this s raised to power 88, don't forget the rule of indices that says that a raised to power m times a raised to power n is the same as a raised to power m plus n. Okay, so we are adopting this to simplify this further. So here we have s raised to power 1, okay, times s raised to power 87, okay, plus 1 over this. We are applying the same rule here. 1 times s raised to power what? 87. Now solving this further, we all know that 87, s raised to power 87 can be splitted as s raised to power 3 times 29. That is, 3 times 29 is the same as what? 87. So this shows that, and also our s raised to power 3 is equals to what? Is equals to 1. Let's call this from equation 4. So from equation 4, s raised to power 3 is the same as what? 1. So that is what we are substituting in here now. So this shows that s raised to power 87 is the same as 1, okay, raised to power 29. So that is s raised to power 87 equals 1. Okay, so more importantly, coming back to this equation now, we have x raised to power 1 times s raised to power 87 is now 1 times 1 plus 1 over s times 1. So finally we have this as x plus 1 over x. This shows that this is the same as what? Minus 1. So that shows that the value of this and this are equal. Thank you, and please don't forget to subscribe to our channel, like, comment on this channel. Thank you. See you next video. Hello viewers, welcome to Ajadi Math class. Today we shall be solving this Olympiad question. Now looking at this question, it says that if x squared over y squared plus y squared over x squared equals 7, find x over y plus y over x. So what is the value? This is unknown. Now looking at this, we are going to see that this is a quadratic equation, while this is a linear equation. So solving this, we should know that the first step in doing this is that this can be expressed in this form. If you have x over y plus y over x all squared, expanding this, okay, we are going to have x over y all squared plus this y over x all squared, and also 2x over y, y over x. The method used in this is when we have x plus a all squared. Don't forget, this is the same as x squared plus a squared plus 2 times x times a. Okay, so that is the short method for expansion. So that was the same thing that was applied here. So solving this further now, we should know that x can possibly cancel out x, while y cancel out what? Y. So this is going to give us x over y all squared plus y over x all squared plus 2 into bracket 1. And from the expression, don't forget that this is the same as this. Okay, so this can be expressed as x squared over y squared plus y squared over x squared plus 2. Now looking at this is the same as the first equation given to us up here. So mathematically speaking, you will agree with me that this is the same as what? 7, as given in this. So we have x over y plus y over x. So by substituting this with respect to this, we are going to have 7 plus 2. So our x over y plus y over x all squared gives what? 9. And from the question, we are looking for x over y plus y over x. So the next thing for us to do is to what? Square root both. Squaring both sides, this square cancel out this, and finally we have x over y plus y over x equals plus or minus 3. So this is our final